Next topic in unit 3 is input output functions analog. In previous video we have seen input output functions digital. Here we will see input output functions analog, serial communication and conditional execution. First, input output functions under analog, you have two different methods like analog pins for reading input and analog pins for reading output. So analog pins for reading input we are using to read analog signals such as sensor reading or voltage level readings. So they provide a range of value, range will be from 0 to 1023 based on the input voltage. So it is labeled as A followed by a number. Example, you can see A0, A1, A2, A3, A4, A5. These are the analog pins in the Arduino board. In the same way, for analog output, here output pins on Arduino board are typically the PWM pins. PWM pins, all pins in the Arduino board are not PWM pins. You have only some number of pins where for that pin number if you have a tilde symbol like pin number 6, pin number 9 etc. these are called as PWM pins. Only to PWM pins you can get the analog output. So these pins can generate analog like output voltages by rapidly switching between high and low states at a fixed frequency and varying the duty cycle of the signal. So the labeled with this symbol on the digital pins, we represent the symbols with this called as PWM pins. Only to these pins you can get analog output. So in order to get the analog input or analog output, you have two different methods, like you have two methods, analog read, analog write. So analog read method is basically used to read the analog signals which are given by the sensor, any sensor which you are attaching. Like if you say some of the sensors like gas sensor can only read analog values. So to that particular type of specific sensors you are using a method called as analog read, where this function can read only analog values. So this analog values can be converted into digital value between the values from 0 to 1023. Actually in the form of voltage, if you see, it will be from 0 voltage to 5 volts. 0 voltage is the minimum voltage, 5 voltage is the maximum voltage. Like if you take gas sensor, if the gas sensor is sensing only little amount of gas, then we say 0 voltage. If it is sensing maximum gas, then we say 5 voltage. So when we learn it theoretically, we will say analog signals in form of voltages, that is between 0 volts to 5 volts. But when it is coming to the programming, we should represent that analog signals into digital value. So 0 volts to 5 volts, that is represented in programming from the range between 0 to 1023. Why only 1023, not 255? This is because in the Arduino board the microcontroller is consisting of 10-bit ADC. ADC is converting analog to digital. So it is consisting of 10-bit ADC. That's why we are taking the range from 0 to 1023. That is the reason why we are considering high value as 1023. So basically analog read method will read the analog signals from the sensor. Next method is analog write. Analog write method, it is used to vary the voltage by adjusting the duty cycle of PWM signals. So whenever you are getting the analog signals from the sensor, in order to execute analog signals from the sensor through the Arduino board, we are using PWM pins in the Arduino board. So that's why we are calling as PWM. PWM is pulse width modulation signal. So what is duty cycle here? Duty cycle is pulse width modulation can be represented in a form of duty cycle. So it will be in a form of wave, where if it is 0 duty cycle, then in the graph you can see only straight line. In the same way 75% duty cycle, 50% duty cycle, like that. If it is a complete wave, one complete wave where the sensor is on, that is called as duty signal or duty cycle. So whenever you are considering one wave, complete wave, we call it as a duty cycle, 100% complete wave. So here you can have 0 percent, it in form of percentage you can assume duty cycle as. You can also say 50% or 75% or 100%. So, one full wave till the sensor is on is called as duty cycle. Next, how we are going to use this method analog read in the programming. For that, we will see the syntax of analog read. Analog read, and you should give a pin number here. So, here pin number will be from A0 to A5 only in the Arduino board. Next, what are the parameters that you are passing is pin. So, pin here represent the name of analog input, pin to read, that is from A0 to A5 on the Arduino Uno board. Next, this is the example for analog read. So, the code reads the voltage on analog pin and displays it on the serial monitor. So, here first what we are going to do, we are going to initialize a value called as int val. We are initializing that value to 0 because now at first sensor is not reading any value. Before initializing it, we are initializing it to 0, and then we are taking a pin number as A3. Among A0 to A5 analog pins, we are assuming A3. Int analog pin is equal to A3. So, to this A3 we are connecting a sensor called as potentiometer here. Next, this we are writing in the declaration part. Next, in void setup we are writing serial begin in the bracket 9600. So, serial begin means in order to provide serial communication between from the Arduino board to any sensor or Arduino board to your laptop. In order to do serial communication, we are using this method serial begin. We will see this in serial communication topic in detail again. Next, in void loop, what are the value you are getting from the potentiometer, what are the value it is reading, getting, that is read by A3 pin, and it is stored in a variable val. That is why we are writing a statement here, val is equal to analog read analog pin. So, analog pin here is A3, which is continuously reading the data from the potentiometer. It is the taking value from the potentiometer and storing it in a variable called as val. Now, what is the value in this val? We want to print it onto the serial monitor. So, that we need to see what is the value it has been read. For that, we are using serial print value. So, whatever value it is read from the sensor is print on the serial monitor, like 256, 254, 225, like that. Whatever the value it is read by the sensor, it is displayed onto the serial monitor by this statement serial.println value. So, this is one of the example where you are using analog read method to read the analog signals. And next we will see analog write. Analog write, here we are using analog write, writes an analog value PWM wave to a pin. So, it can be used to a light, a LED, or you can check the brightness of the LED, or you can see the rotation of the potentiometer like that, or servo motor. In order to detect all these, we can use analog write. So, after a call to analog write, the pin will generate a steady rectangular wave of the specified duty cycle until the next call to analog write or a call to digital read or digital write on the same pin. The meaning of this is what are the duty cycle you are generating. That means it can be a 0%, 50%, 75 or complete 100%. Depending upon the duty cycle, specified duty cycle, you are going to get a PWM rectangular wave. So, syntax for using this analog write is analog write, we are providing the pin number and the value. So, the parameters whatever we are passing pin, this pin represent Arduino pin to write it, allowing some data types like integer value or string value, character values you can use here. What is the type of the value you are using? Next, value here. What is the value here is a duty cycle, that is between 0 to 255. So, 0 means it is low, off, the signal is off. If you say 255, it is the maximum range where you say the signal is on. So, this is allowed in the value in the syntax of analog write. So, you are going to provide a pin number and what is the value, maximum value or the low value that you are going to represent in the value of the parameter. So the example where we are using analog write. So this example says sets the output of the LED proportional to the value read from the potentiometer. So you are connecting the LED and the potentiometer to the Arduino board. Depending upon the potentiometer, the value of the potentiometer, the LED light will be brightened. The brighten will be more or brighten will be less, or total blinking like this, on or off. Anything, it depends upon the potentiometer. Depending upon the potentiometer value, the brightness of the LED increases or decreases. So for that, to catch those values, first we are taking int LED pin is equal to 9. Specifically we are taking this 9, 6 because those are PWM pins in Arduino board. Next, int analog pin is equal to 3. So to this pin you are connecting potentiometer, and to the pin 9 you are connecting a LED light. Next, we are initializing the value to 0. In void setup you are writing pin mode. Pin mode is important because to which what are the sensor you are connecting, whether that sensor you are connecting as an input or output, that should be compulsory specified in analog write. But whereas in analog read this is not compulsory, but in analog write you should mention this pin mode method. So in this pin mode method you are going to write LED pin and then output. What is the LED pin you are using, and you are making it as an output. Set the pin as output. Next, in the loop you are going to write main description where analog read method is used, where the sensor value is read in a variable called as analog pin. That whatever pin you are taking, whether A0, A3 or A5, the sensor values are connected in the variable analog pin. And now what are the value you are getting? Analog write method you are using. Analog write method, 2 parameters you are taking, LED pin comma value by 4. So in order to calculate the values of the range from 0 to 255, analog read values goes from 0 to 1023, analog write values goes from 0 to 255. So this part is important, you should remember. Analog read values 0 to 1023, analog write values 0 to 255. Based on this value calculation, what are the value you are getting, based on that the LED will glow accordingly. So next topic is serial communication. So serial communication in Arduino board is one type of method where you want to send the data from an Arduino board to your PC or Arduino board to your laptop. So in order to transfer the data, we are using this technique called as serial communication. So serial communication is done through UART protocol. So UART is Universal Asynchronous Receiver Transmitter. In order to perform this serial communication, you are having 2 pins in Arduino board. Those are TX and RX. TX is the transmitter pin, RX is the receiver pin. These are the 2 specific pins for using which you can do serial communication. So whenever you are doing some serial communication, UART protocol is being used. Next is baud rate. What is baud rate is, it will tell us the speed of data transmission, to how much speed the data is transmitted over the serial connection. So it is measured in bits per second. So baud rate is the speed at which data is transmitted over serial connection. It is measured in bits per second. So common baud rate we include when we use serial communication is 9600. So this much bits per second. We have seen in the previous PPTs where we have written serial begin in bracket 9600. So serial begin in bracket, whatever you are writing is a baud rate, to which speed the data should be transmitted, that it represents. Next, serial communication functions. What are the different types of functions that you are going to use for serial communication? Serial dot begin. Serial dot begin, you are going to mention baud rate. We have seen serial dot begin 9600. So whatever value you are measuring, that tells the speed of the data transmission. So in order to initialize the serial communication, we are using the method serial begin. Initializes serial communication with the specific baud rate. Next method is serial dot print in bracket data. So whatever the data is being sent, it is going to be printed onto the serial port in form of numbers or in form of characters or in form of strings. Next, serial dot println data. So sends data to the serial port followed by the new line character. So whatever the values which are read from the sensor to the Arduino board and you want to know what is the value that has been read. In order to know, you want to display it onto the serial monitor. In that case, you say serial print or serial print L. Next, serial dot read. It reads incoming serial data byte by byte. To read the data from the sensor, you are using serial dot read. Next, serial dot available. Serial dot is available. If you are not using this serial dot available, you will be getting output in the serial monitor in a form of some garbage values. You can just say serial begin and then serial read and say serial print. You can check with that, you will get all the garbage values. In order to avoid those garbage values, we are using serial dot available. Serial dot available is whenever the serial communication is on. You can put a condition like if serial dot available is equal to 1. That means if serial communication is on, then read the data and then transfer the data. For that, you are using serial dot available. Returns the number of bytes available to read from the serial port buffer. Next is serial monitor. Serial monitor is an important tool where you can see what is the value read by the sensor. This is the example for serial communication. So in void setup you are writing serial dot begin. This tells us initialization of serial communication has been begin with some baud rate. So this you are going to write in void setup only because I want to execute this method only once. Next, in void loop you are going to write actual logic. So if serial dot available greater than 0, if the communication is on, then read the character one by one by using serial dot read, and whatever the values you are reading, you are collecting in a variable called as receive char, and then whatever you have received, you are printing it onto the monitor using serial dot print NL. And if you want to send some data to the serial monitor, you can say serial dot print hello world. This directly we are sending the data. Here we are not concerned about any sensor reading the data, whatever the data has been read by the sensor. All this we are not concerned, just we want to print hello world in the output serial monitor. Serial dot print hello world you can say. Otherwise, if you want to see what is the value read by the sensor, you are going to use these methods. Next, if you are printing some value A, if you want to print the ASCII value of A, then we said serial dot write in bracket with a colon you are writing A, you will be getting ASCII value of A. With some delay, you want to print the values again and again with some delay, then you are using delay method. So this is the example of serial communication. Next, conditional execution. Next statements like last class you have seen variables, here conditions. So you can use conditional statements like if statement, like example if sensor value greater than 500. You can use these conditions like in digital write LED built in high. So whether the LED value is high or low, brightness is maximum or brightness is low, like that you can check using some of the conditions. You can use the conditional execution statements. Second type of condition is if else statement, like if sensor value greater than 0, what to be done, and else what to be done. So like these two conditions also you can keep in the programming. So all these conditional statements you practice in the while programming. Next statement is else if sensor value greater than 800, then else if the value is greater than 500. If value is greater than 500, this if block else if block will be executed. If the value is greater than 800, then this if block will be executed. Next is switch statements. If you want something to be in different types of statements like switch option, case 1, case 2, case 3, case 4, and the break default statement. According to the input value, whatever the input value matches with this label, that particular block will be executed. If nothing is executed, default statement will be executed at least once. So these are the different types of conditional execution statements like if, else if, switch. You can use all this in programming. Thank you.